Hello everyone and welcome to my fifth Rust Quickie. In today's Rust Quickie I want to talk in more detail about variables, and I want to show you some things which are specific to the Rust programming language. As you already know from my previous Rust Quickies, you can define a variable with the let keyword. A variable declaration in Rust is called a variable binding. Means we have a value, like the value of 12, and we bind that value to a variable, like in our case to the variable a. So this is a so-called variable binding in Rust. So we have here the variable a with the value of 12, which we print here out with the print line marker. And as you also already know, you don't always have to specify the data type. For example, I'm defining here a variable called p, which stores the value of 3.14, and I haven't specified here any data type because the data type is chosen by the Rust compiler automatically. As you can see, the Rust compiler has chosen here the 64-bit floating point data type. So this is also a specific to Rust that you don't need to define a data type. The data type is chosen automatically by the Rust compiler. Another interesting concept in Rust is also the so-called variable shadowing. As you can see, I'm defining here again the variable a, which we have already defined here. So we are defining here the same variable multiple times with the same name. And as you can see, when we do a cargo build command, we are not getting any error from the Rust compiler because this is allowed in Rust. That's called variable shadowing. You're just defining a variable multiple times with the same name, means you're just redeclaring that variable. So we have here variable a, and then we redeclare that variable again. So when we do a cargo run command, you can see the value of a is 12, value of p is 3.14, and the value of a afterwards is 89 because we have just redeclared that variable. Another very important concept in the Rust programming language is the fact that you can't change variables after their declaration, because a variable is always immutable by default. As you can see here, when I'm trying to assign the value of 42 to the variable a, after its declaration, we are getting here an error. Cannot assign twice to an immutable variable. It's the same when we do a cargo build command. We are getting the same error message. Means you can't change a variable after you have declared that variable. A variable is just immutable by default in Rust. If you want to change variables later, you have to define those variables as mutable. Means when you define here the variable with the let keyword, you also need to use the mute keyword, let mute a. This means now that you can change that variable at a later point in time. Means when we do a cargo build command, everything has completed successfully. Let's do a cargo run, and you can see now the value of a is 42. We have initially defined that variable binding with the value of 12. We have changed that one later to 42, and now it works because we have defined that variable as mutable. So this is very important in Rust. If you want to change a variable value at a later point in time, you have to define that variable as mutable. Another interesting question in the Rust programming language is what happens when you have some operation and that operation produces an overflow. Imagine the following scenario. I'm defining here a mutable variable k. I'm initially assigning the value of 10 to it, and therefore the Rust compiler chooses here the data type of an integer which is 32 bits wide. And then in a for loop, which we are running 15 times, I'm just multiplying that variable with 10 over and over and over again. And of course, at some point in time, we are generating an overflow. So what happens now when you're generating an overflow in Rust? Well, it depends. If you're running a debug or release build of your application. In a debug build, your application just panics, means the process of your application just terminates with an error message, and in a release build, that operation that produced an overflow just wraps around and returns you as a result a negative number. Let's demonstrate that. By default, when we do a cargo run command, without any additional options, you are running a debug build of your application. So let's do that. And as you can see, we are running here our multiplication just a few times. And at some point in time, we have here multiplication with an overflow, and your process just terminates. That's a so-called panic operation in Rust. When we run a release build, the multiplication just wraps around and returns you as a result a negative number. Let's do a cargo run command, and now with dash dash we specify that we want to have a release build. As you can see, when we run now our application, no panic anymore, everything is fine, but you can see from the output your integer value just wraps around. Sometimes we are getting minus values, so we are just getting a different result. So this is also very specific to Rust. By default, in a debug build, your operation just panics if you have an overflow, and in a release build, your operation just wraps around to a negative number. Of course, getting a different behavior from your application, depending if you're having a debug or release build, is not always a good thing in Rust, and therefore Rust also provides you some specific operations. For example, as you can see here now, we have here a checked mul operation. Means the multiplication just panics now always if you have an overflow during the multiplication. Doesn't matter if you have a debug or release build, the multiplication just panics always. And as you can see, you have here a lot of different checked operations. Checked division, checked anything shift left, shift right, for sub operation. So for all major operations you have checked operations, and it just means that the operation just always panics. It panics in a debug build, it panics in a release build. So let's run now our program with the checked mul operation. Let's do here a cargo run. This is now a debug build. As you can see, it panics with an overflow, so that's the error message that we are returning here from the except method call. And now when we do a cargo run command with a release build, we are also getting our overflow. It also panics. Previously, with the normal multiplication operation, the number just wrapped around, it produced a negative number, and now we are getting that panic. So you have just a deterministic behavior. And you can also do it the opposite way. So we have here a second code block. Let's use that one now here. And now instead of a checked operation, I'm using a wrapping operation. Means with the wrapping operation, your operation just always wraps around. It wraps around in a debug build, but it also wraps around in a release build. So let's run that application again. Cargo run command. We are doing here a debug build. We have again the wrap around, as you can see from the negative numbers. When we do a release build, we also have the same expected output. So this is very important. By default, when you're doing normal operations like additions, subtractions, you're doing multiplications and so on, it depends if you have a debug or release build, but with the checked or with the wrapping operations, you always have a deterministic behavior. So please keep them in mind when you're working with these operations. So this is very important to Rust. In today's Rust Quickie, we have covered a lot of additional things regarding variables in Rust. As you have seen, variables are always immutable by default, means when you want to change variables at a later point in time, you have to mark them as mutable with the mute keyword. And in addition, at the end, I have also talked about checked operations and wrap around operations in Rust, which are also specific to Rust. So please keep them in mind when you are working with such things in your applications. So thanks for watching to my latest Rust Quickie, and I'm already looking forward to welcome you next week again, where I want to talk about arrays in Rust. So thanks for watching, stay tuned, and see you soon. Thank you.